Hey guys, welcome to day 3 of Science and Technology Digital Learning. Like I said in the intro video, hope you guys had a good spring break. I'm really hoping we get back together here pretty soon to be able to complete our mousetrap cars and some of the other projects that I had in mind. I'm going to try something today. Hopefully, we're going to be able to get a little bit of hands-on activities going on, but we'll see. I also mentioned this in the video. I haven't got everything graded today, but I'm going to go ahead and make sure, by the end of the day on the 30th, I'm actually recording this on Sunday evening, that I have all the grades up to date. If you do not see your grades when you come in to check in class, shoot me an email so I can get them taken care of for you. So we've been talking about simple machines. We continue talking about simple machines right now. So how do you do a gizmo on wheel and axle? And I'm not going to have you do a gizmo right this minute. But what we're going to do is we're going to talk about the next simple machine, and that's a lever. So I have a little thing right here I made. These are the parts or the things that we're concerned about when we talk about simple machines. For levers, the first is effort. This is the force that we're going to put in to lift or move whatever it is that we're trying to do. The second is the lever itself. This is the actual device. A lot of times it's a long pole or it's a board or something like that that we're going to actually move back and forth. The fulcrum, this is where we pivot whatever it is we're doing. And I'll show you some pictures here in just a second of that. And then finally the load. And the load is what we are trying to move with the lever. I mean, you usually just don't do a lever for the heck of it. There's usually some kind of work that you need to be done. The load is what you're trying to move, and the effort is the force you're going to use to move the load. And remember, the whole process or the whole purpose of a simple machine is to reduce the effort needed to move the load, to do the work. So hopefully this will make a little more sense here in just a second. So we actually have levers that we use quite a bit in our lives. You may not realize it. Probably one of the easiest things that people will remember for a lever is a seesaw. Hopefully you guys had a childhood where you were on a seesaw at some point. You have a friend on one side, and you kind of raise him up in the air, and you're on the other side, and you push off with your legs, and it tilts back the other way. In the very center of it, this is the fulcrum. So you have whoever is up in the air, that's the load, and you want to get the load down, so you put your effort in by pushing up, and it moves back and forth. So you have fun jumping back and forth on a seesaw. Pretty simple way to do that. So there are 3 kind of levers that we're going to talk about. And what we got here is we have a first class lever. And this is most like a seesaw. So the fulcrum is the pivot point. The load is on one side. And as we push down on the other side of the lever, the line here, we push down and the load will go up. And now we can make it harder or easier by moving the fulcrum back and forth. If I move the fulcrum closer to the load, it actually requires less effort to push it down to raise it up. But the thing is, you don't go up as far necessarily. So if I move the fulcrum back this way, it actually takes a lot more effort to lift the load up. So usually you want to find a good balance in there. The next one, and like I said, this is kind of like the teeter-totter. The second class lever, we have the fulcrum out on the end, and we're going to pick up on the ends. We're going to put our force on the end of this by lifting it up to lift the load up. One of the best examples that I can tell you about this one is a wheelbarrow. A wheelbarrow is a great example of a second class lever. And then finally, there is the third class lever, which has a fulcrum on the end. The effort is in the center, so our work is actually going to be in the center, and the load is on the far side. Tweezers. What do we call these things? Fingernail clippers. These are all examples of a third class lever. Also a baseball bat, a shovel, um, because you lift in the center, but you're pushing your arm down. So a shovel, you come in and lift up like that. So these are your three different kind of levers. This is what I want you to concentrate on today. So what I'm going to do is I'm going to have a video on here for you to look at that's going to deal with levers. But what I want you to do, your project for today, you have until the start of the Wednesday class, is to create one of each type of levers. I want you to use your phone, your computer, or whatever, but I want you to upload into Google Classroom a picture that you created of a type 1, type 2, type 3 lever. You can, set something on your table. Let's say, like, I got a tube of lotion here, and this would be a type 1 lever. So, but what I want you to do is I actually want you to have something that you're going to lift with it. Uh, Hopefully, maybe your parents have something in the garage, some boards, some wood. But worst case scenario, you can use pencils and pins. But I want you to point out where the effort is, where the load is, and where the fulcrum is, and then also what the lever is. So this will be a video that you're going to send me of each one of these things. So that's your project for today for Science of Technology. Again, I'm available from 9 to 11 a.m. Monday through Friday. If you have any questions, feel free to give me a holler, and hopefully I can clarify that a little bit more for you if you got any questions. Thanks. I'll see you guys soon.